Hello guys, in this video tutorial I'll be teaching you how you can compare between a raised to power b versus b raised to power a. Which one is greater and which one is smaller. So let's get started. So we have to consider some other forms. Multiplying raising power by 1 by ab. So it becomes a raised to power 1 by a versus b raised to power 1 by b. So now considering a function fx, which is x raised to power 1 by x, we must also note that x can also only belong to r plus. So now fx derivative f dash x will be 1 by x raised to power 1 by x minus 1 plus, using function of a function rule, dx ln x into 1 by x derivative, it's 1 by x square. By taking common, we will get x raised to power 1 by x. This x will be minus 2. Minus 2 will be common from here also. So it will be 1 minus ln x. F dash x is equal to 0 for x barabar e. Now sine of f dash x. If we consider a function e, it will be either function will be either maxima at e, will have maxima at e or minima at e. So if we will go ahead of e, the sign it will be more than 1, so it will be whole negative value. So it will be negative here and positive here. So this implies at x equal to e, there will be maxima. So now by only this much information we can compare a raised to power b and b raised to power a, but for the sake of simplicity I will draw the graph of it also. So using concept of limits, limit x tends to 0 plus, to be precise, 1 raised to power x will be, since x is going towards 0, we can use e raised to power formula, which is e raised to power gx fx minus 1, which is gx x minus 1. So if its x is tending towards 0, this will be minus 1, and minus 1 divided by 0, it will tend to minus infinity. So the whole value will tend to 0. Now consider limit x is tending towards infinity, x raised to power 1 by x. Now we cannot use e raised to power formula because the function should be going towards 0, but here it's going towards infinity. So we can use e raised to power ln x raised to power 1 by x, which is e raised to power ln x by x. Using L'Hospital rule, we can use ln x is 1 by x is 1, and x is tending towards infinity, so the whole value will tend towards 0, and e raised to power 0 is 1. And all information we have got that at infinity, at x tending towards infinity, we approach 1, at x tending towards 0 we approach 0, and there is a maxima at e. So the graph of function fx equals x raised to power 1 by x will look something like this. It will be asymptote towards 1, and this will be x equal to e, and this will be e raised to power 1 by e. So we can now say that e raised to power 1 by e is greater than any value of x raised to power 1 by x. So raising e raised to power x is always greater than x raised to power e. Hence this solves a major occurring problem that e raised to power pi is greater than pi raised to power e. It is only a special case where x is equal to pi. It is always true for x belongs to R plus. Now let us compare a and b. So now the question arises, if a and b are different, so the function is like this. So if a and b both are greater than e and a is greater than b, then since function is decreasing for x greater than e, that this implies fa will be less than fb b, or a raised to power 1 by a is less than b raised to power 1 by b. Raising to the power ab, we will get a raised to power b is less than b raised to power a for ab both greater than e and a greater than b, and if ab both less than e and a is greater than b, then a raised to power b is greater than b raised to power a. But we should keep in mind that this is always true for any positive x. And now the question arises, if a and b are either right side of e and left side of e, i.e. greater than e or less than e. So the simple answer is we cannot compare if a and b are left and right of x is equal to e. For an example, say a is equal to 2, b is equal to 3. Of course it is greater than e, it is less than e. So 2 raised to power 3 and 3 raised to power 2, it is 8 and it is 9, so it is greater than. But it is always not true, right? Because we have seen the more power to the more value to the less power is greater than, which is not true for the case of pi, since pi is greater than e. But pi raised to power e and e raised to power pi, this is not true. We have already given that pi raised to power e is less than e raised to power pi. So we can only compare by calculus for AB belonging to either side of x equal to e. So thanks for watching this video. Hope you have got an idea with this graph, which is very useful, and we should always keep in mind that e raised to power x is greater than x raised to power e for all positive x, and a raised to power b is less than b raised to power a, provided a, b are greater than e and a is greater than b, and vice versa if they are less than e. Thanks for watching this video.